So this lecture is not directly relevant with any lab or any project iterations, but it's more relevant to you for learning software fundamental, because this is a core concept in software engineering. So when we mentioned in the first week, when we introduced the software development lifecycle, maintenance is one of the core steps in a software development lifecycle. So we have like design, development, testing, and then we have maintain. So imagine that. Okay, so what if you are building a large software project, right? And in the middle of your development process, someone dropped your group and a new member joined your group. Do you think it would be better that if this new member can quickly catch up with your progress and contribute to your project? Or do you think it's okay, the code we wrote is functioning, but this new member really struggled to understand what we wrote and really struggled to contribute to the project? That would be really bad, right? So we want to write code that when new people come, they can easily catch up with the project. And also, we have a lot of students like finishing 1531, they start to write their own hobby project, and they open source the project on like GitHub or Bitbasket or GitLab, right? So when you have an open source project, what you want is this project can last for longer, right? You also want other people to contribute to your project. So you need to make sure that your code, your project is easy to maintain so that other people can contribute to your project. Right? So it can make it can be more impactful, right? But in other scenarios, like why do we need to care about maintain? Like other than new people joining or open source program want to have more contributors, but what if it's just a Netflix? Like what if for Netflix software project, for YouTube software project, and for this kind of Facebook projects? So in reality, the software evolves all the time. It changes all the time. Maybe you want to have a new feature, right? For YouTube, you want to have a new feature that you can create a community, like people comment on each other's videos or whatever. So you want to have these kind of new features. Or you may want to improve the performance, right? The quality on YouTube is better, becomes better, right? So we are always making changes to our software projects. So no matter whether we have new people join, people left, so the software project is always changing. But we do not want this kind of change to break your product, to break your software project. So well-designed software is maintainable. So maintainable software resists the tendency to break as the software changes or grows. So this topic is very critical. Shh. Thanks, everyone. Yeah, so this topic is getting more and more critical with the rapidly iterative nature of our software. So Netflix, do you know how often Netflix update their software? Many times per day. They are always updating their software, right, to make sure they meet with the customer, that the users need, and make better performance. Right, so we need to make our software maintainable. Okay, and maintenance also not only cares about change in people, change in requirement, change in performance, but also is relevant to bugs. So there's no bug-free software, especially for large ones. So we are always fixing bugs. So writing maintainable software makes sure that when we fix bugs, it won't introduce more bugs. All right. And by writing, how can we get maintainable software? There are a couple of ways. The first one is writing tests. So writing tests, make sure that when you make changes to your projects, if there anything goes wrong, you will always get notified, like where this is something went wrong here, right? When you write just testing. So writing good tests is important to have a maintainable software. Another way is to have good system design. So this is more higher level, like system design. So this is this model, that is that model, and how the different models work together. And we'll cover this in a future lecture. But in this lecture, we'll focus more on the code design. So how can we write code that is maintainable? Okay, so both in a high level and in a low level of details. So code design is something happens in between of writing tests and writing our code. So it's when you know what you are going to write, but you need to consider more about how you write this piece of code. And with our project or with our course, you may feel like the due is always pretty soon, like you have the urgent need to finish every function. This is also true in reality, like in industry. We want to finish a feature as soon as possible or fix a bug as soon as possible. So sometimes we may ignore writing good, well-designed code. So this is the tendency, but we need to make the effort. Like first we need to know what kind of code is maintainable, right? And then we need to try to write maintainable code. At the beginning, it may be hard, but when you get a good habit, you do not need to. Well, you still need to spend some effort in that, but it won't be that hard and spend that much time or energy. But it pays off in the future. Like when you make change to your project, right? It pays off in the future. So when we want to write maintainable code, there are 6 design questions that we want to ask yourself, not ask me or not me ask you. It's just ask yourself when you write maintainable code. And we'll go through these 6 one by one, these 6 questions. The first one is there one source of truth for this? So this happens when you have the same logic here and there in your code, and you want to change this logic. But if you have more than one place that has this logic, you need to change the logic everywhere, like having this logic. Well, if you forget to change one of them, or if you change the logic differently in different places, it will cause issue. So the way is to abstract that, maybe write a function or wrap these 2 functions together or whatever. But you need to have only one source of truth for a case. So let's have a look at this one. So this is an example. Right. So this is the example. So have you used ArcGUI before? Have you used ArcGUI in any lab or no? No? No. Okay, so ArcGUI is similar to when we use prompt function, like read the user's input. And when we use ArcGUI, we can also get user input, but in a different way. So let's have a look at this example. Let me go to the correct folder. Okay, I'll just run this function first and explain to you how it works. Run ts node, and this is called dry dirty. Okay, so this is normally when we this is how we normally call a TS script, but here we have something more. Like after that, we can have another element in this command. Like this is the user input. You can have 2, 3, 4. For example, what if we have 3 here? It reads this 3, okay, and use this user input in your script. Okay, so we have like in this example we used npm run ts node dry dirty 3. So this thread is the argv2. So this is how we get user input from terminal. So this is, so after npm run, this is, this is 0, this is 1, and this is 2. So this is argv0, argv1, and argv2. And this is the length of the user input from this terminal, this command line. And the length of this is calculated using argv.length. And for this particular script, it requires the length to be thread, otherwise it will just exit this program. So it comes from after npm run. So npm run is the standard, and then your script here is the nts no dry dirty thread. And this number is the pass in argv2. Like this is 0, 1, and 2. So number here is thread. So when number is thread, it runs this part. Okay, but it can also be 2. So, for example, 1, it is 2. This is what it's called here. So it runs this if logic here. All good? Yeah, so this is another way of reading user input from the terminal, from command line. Okay, so now let's have another look at this example. So if the user input is 2, it do this. If there is 3, do this. Otherwise, exit. Okay, so this is the logic. So is there any logic or truth that is in more than one places? So how can we make this script better, make this program, this code better, design better? If you don't know yet, so this -4 I is the same with I like times thread. It would not times thread. So they are the same, right? But just in different ways to write the code. Yeah. Sorry?
You could take the for loop in a different function.
Okay, so we can extract this for loop here and here. Is that what you mean? Yeah. Yes, that's right. So we are kind of having the same logic here and there, and the difference is that we are using different ways to get the power, like max power here, but they are actually doing the same thing. And in this console log, this 2 or 3 is also determined by here. So how can we make it better? Yeah?
You can either use math.power or just asterisk, like have a consistent way of phrasing something.
So either use this one or this one so that it's consistent? Yeah, okay. So what about we use this one? Because they are the same anyway. What else we can do? Oh, I need to change it to thread here. What else we can do? Yeah?
We don't have to have just 2 separate for loops.
We don't need to have 2 separate for loops. How can we do that? What about I change this one to number, this to number, this to number. Oh, this needs to be a dollar number. Oh, sorry. Dollar number. Is that right? And same here. And then if or, so what we can do is if number equals to 2 or 3, we just run this for loop. Otherwise, we exit, process.exit. Right? So if we want to change, for example, rather than power +1, we changed the one place, but we forgot to change here. It will cause issue, right? So, yeah, it's pretty straightforward. Yeah, anything else? Anything else we can make this better? Like we are... anything else we can do other than having the for loop at only one instance? Yeah. I'm looking at online. Any source from online students? Well, waiting for online students to get back to me. Else, what I'm going to do is to delete this part. Yeah. Okay. Any source? No. It's my online students. Any source from here? Anything we can make? Anything more we can do? No? Yeah, so this is from previous term. So a student mentioned that we saw process exit 1 here and here. So can we make a function called exit 1 and then maybe only have something called exit here? So we need to define this exit function, and what's in this exit function is process exit 1 and here. So that is consistent like what exit does. So this is suggestion by a previous student. But it's okay, like we'll come back to this. I'm not too sure whether it's good or not, but we'll come back to that one. But this example is mainly to show you that it's better to have the truth, like one source of truth in your script. So that when you make changes, again, like when you make changes, it's more robust. Another question that you may want to ask is your code as simple as possible? Right. There are a lot of different ways to solve problems, but we want to get the simplest way to solve the problem. So the less lines that you have in your code, the less lines that you need to maintain for your script. For example, if you have 1,000 lines, you need to maintain those 1,000 lines. But if you can do the same thing in 10 lines, you only need to maintain those 10 lines. Right? So the less is better. Right? So write as simple as possible. So every line of code you wrote, you want it to be bug-free. So this is what we call like KISS principle. So you may have heard this KISS principle somewhere before, right? So this is not only for JavaScript, or it's not only for 1531. So this approach is called keep it simple, stupid. So this is a common principle in writing good designed or well-maintained code. So clear code is more important than clever code. Okay. Let's have a look at this example. So the example asks us to write a function to generate a random string with up to 50 characters that consists of lowercase and uppercase characters. How are you going to solve this problem? Checking online. Yeah, you could make the process exit in 1 if similarly you have to add a persistent. Yeah. So how can we do that? Okay, so first, like we can write everything from scratch, right? So I can maybe create a string which is like have 50 characters and add 1 and then 1 and then so in a loop with 50 iterations, right? So this is one way, but there may be other ways. Maybe I can see if there's any library from NPM, right? Maybe we can just build on top of other people's code and just use one function to just call their function for once. random string, maybe. Random string generator, random line string. So you can see that there are a lot of examples, a lot of libraries that can do this. Maybe you can choose one. Maybe this is a good one. Like it has a lot of downloads weekly. Potentially it's a good one. And then we install this random string. And then random string generate, would just generate a random string. Random string generate 7, it will be create a string with the length of 7, has 7 characters. So in our case, we can just say random string dot generate 50. But there may be some number in that. So maybe we want to have only characters like letters. So we can have random string generate length is 50, char size is alphabetic. That's it. Right? So you can have it just super simple. You do not need to write everything from scratch. And this tends to be a very robust library because it has a lot of downloads. It's quite reliable one. But there may be other libraries that you can try and use. Yeah. But do not use like overcomplicated ones. That's it. So we solved this first example. Write a function that prints what day of the week it is today. What day of the week it is today. I think there's a JavaScript function, right, that can print out the day of the week. I can't remember exactly, but I can always check, right? JavaScript day of a week. JavaScript, yes, getDay method. So there's a method in JavaScript that we can use directly to get the day of the week. Right, so these are some examples, like we build on top of other people's code so that we have less lines in our code to maintain. Right. Okay. Write a program that takes in command line arguments. Okay, we have already saw 2 examples for this. Like one is use prop function, another one is use the argv. Right, we can get command line arguments. Right, so we do not need to write our own functions. We just use the libraries already exist for JavaScript. But this is not always the case. There are still many cases that we need to write our own codes. It's just giving you some reminders, like if there's some code like we can use directly, we do not need to write our own. But in many other cases, we still need to write our own codes. Okay. The other question is this over-designed or under-designed? Okay, let's come back to this example, the mass power one. So we mentioned that maybe we can just define a function like abstract this process exit one in a function called exit. So this is actually an example of over-designed code if we abstract that like this. Because, so you may not know yet, but as you write more code like in software engineering, you may know that process.exit one is something that programmers know what is it. But if you have something like just exit, they don't know what that is, and they need to check and find this function, find where you define this exit function and see what is in that. So this is over-design. But if you have just a process exit one here, like everyone knows what that is. All right, so that is actually over-design. But under-design is the original example we had, like we had a for loop in 2 different places. So that is under-design, like you need to design it better. But we abstract the script too much, it might become, over-designed. So sometimes repeating ourselves twice, but only twice, is okay sometimes. Unconditional conforming to a principle is a bad idea. So you do not need to conforming to any of those principles, but sometimes add complexity back in. So this is hard to balance actually, like whether we are over-design or under-design. So this is hard to balance at the beginning. So as a beginner, like software engineering beginner, most of us will write like under-design code, like can be designed better. But gradually we may find us like over-design stuff, starting to over-design stuff. And then we can get a good balance. Like when we write more and more code, we can starting to get a good balance of well-designed code. Okay, so another two questions we may want to ask is, are related modules kept close together or are unrelated modules kept far away? So this is when you want to change a feature, for example, register. You want to have all functions about register close to each other. So when you make changes, you know, well, there's another function that I need to change about like register. But if they are too far away, maybe you forgot to change that, or maybe you can't find where is it. Right? But if you keep relevant things together, it kind of work as a reminder. Well, like when you change something, there's something else that you need to change. And you also know what has been changed in the relevant functions. And actually, we'll talk more about this in a future week as well. So we won't make it too complex today. This is a very, very common mistake that I made this mistake a lot. Am I speculating about how necessary this is? So this is, so to make it short, like we want to start necessary things. So when you write a function, write a piece of code, or write for a feature, ask yourself, is this essential? Is this necessary or not? So we have a lot of perfectionism. Like we want to do things perfectly. We want to write good code. We want to have a good project. We want to have a good software. So sometimes we may think, well, I want to add this one. I want to add this function so this can be better. Or I want to have this feature. I think have this feature is great for my product. But before you do that, ask yourself, is this essential? Right, so we do not want to add overcomplicated things, make your software overcomplicated. That can introduce maintenance issue. Right, so start with essential things. Is this necessary? Right, ask yourself, is this function necessary? Right. This is also true when you write the test cases. Right, so there may be some test cases isn't necessary, right? And when you write that, you need to also maintain that as well. And this is a principle called you aren't gonna need it. So this is like KISS principle. So this is a key principle of software design, like you aren't gonna need it. So you can see that a lot of programmers, software engineers make this mistake. Like they overcomplex things. And the seventh question to ask yourself, does this follow standard convention? Right, so you won't want to write your web application backend in C programming language. Right, so this is not a convention in writing web backend. Right, so if you write C in backend, you are going to introduce trouble for yourself. There will be less resources for you. Like how can I write a project backend in C? Right? There's not much resources for you, and people don't do that. Right? And this can also be about how the style, like how you write the style, like uppercase, constant, or how we use the library choices, like we use Express Server. Because Express Server is popular in industry, like everyone is using Express Server for their backend in industry. So this is why we are using it, right? Then there will be a lot of resources, and it also make it easy for other people to understand your backend development, right? Because they are familiar with Express, and there are a lot of resources. Any questions so far? Yeah, I found this lecture every term is very hard to deliver. Maybe because it's kind of more boring comparing with like more practical lectures, because a lot of conceptual things like me talking, not much demonstration. But these are some questions that at least we want you to know. Like when you write your code, you know those are the key principles. Like you want to remind yourself to follow. For example, keys. For example, what was that? Keys. This is called Yageti, which is like you aren't going to get it. So these are very common principles for code design. Okay, where are we? Yeah, this is. Yeah. Okay. So another terminology that you may have seen or will see is called refactoring. So refactoring is a common process in software engineering that after you already written your code, you may go back to your code and refactoring it, like means restructuring existing code without changing its external behavior. Like the function still does this behavior, but you make some changes of how the code looks like. This is called refactoring. And refactoring is very, very common. It is very, very common. But refactoring is strongly discouraged if you do not have a good test suite. You may introduce more bugs to your software programs. Okay, I don't want to make this lecture too long because